2.6 is graphs of rational functions. Now, when we talk about rational functions, let me remind you we're talking about functions that are fractions, where we have x's in the denominator. And so when we start talking about x's in the denominator, we start talking about vertical asymptotes. Okay, so we start talking about graphs. I'm saying start, like we haven't, but so we've talked about these some, but where the graphs are broken into pieces because of our vertical asymptotes. We're also going to have horizontal asymptotes. Okay, so rational functions. Now, a rational function is one written in the form f of x over g of x, as I just said. Fraction that includes x's definitely in the bottom and or the top, where f and g of x are both polynomial functions. Now, in this first example, we're going to talk about the domain. And I'll have to look at homework here in a little bit, but I think this is what your first section of homework talks about, like 2 and 4 or 2, 4, 6, something like that. But they want us to find the domain, but not just our traditional find the domain. We're going to use limit notation to express this. Okay, and we're going to be writing a whole bunch of limits today. Okay, that like homework is writing a whole bunch of limits, so we're going to practice that. Now, when we talk about finding the domain, we're talking about domain are my x values, yes. So we're talking about where can x exist, where can x not exist.
We graph it.
We're going to graph it by hand in a little bit. Well, actually, yeah, we're going to talk about the graph, but it's more of looking at this equation and coming up with the pieces that make the graph. Now, what do we know about denominators? Denominators of fractions cannot equal 0. True statement? That's an old statement that you've heard time and time again. Okay, so first thing I'm going to do, since denominators can't equal 0, first thing I'm going to do is set my denominator equal to 0. Okay, we just said denominators can't equal 0, but first thing I'm going to do is set the denominator equal to 0 so I can find where can't it exist? Where do we have that issue? So if I set my denominator equal to 0, we're going to know what? X cannot equal 2. True? Okay, this graph will not exist at 2. Now, okay, digging those brains, what is going to be at x equals 2?
A hole.
Not a hole.
Asymptote.
A vertical asymptote. Or I should have said what type of asymptote, but here's the deal. Now, if there was an x minus 2 factor on top also that would cancel, then we'd talk hole. But when any place your denominator equals 0 is going to provide a vertical asymptote. So there's a vertical asymptote at x equals 2. Okay? So right there, we know that about our graph, right? Which means I know my graph is going to be broken into at least 2 pieces. Okay? Now, review. What about horizontal asymptote? Do you remember those rules?
Yeah.
No, I think you're thinking more of range.
When you look at like the top. No, you look at you set the bottom. You can use no. What's the one where you have the like wherever your biggest power is at?
That's what we want to talk about. Wherever your biggest power is determines what type of horizontal asymptote we have.
Oh.
Okay. Where's my biggest power? On bottom, yes?
So it's equal to 0.
We have an x to the first as our biggest power on bottom. And so when your biggest power is on bottom as x to the first, there is indeed a horizontal asymptote at y equals 0. And again, that's because we're going to review this a lot today. Bigger power on bottom. I'm writing really small there. I don't even have that explanation in my notes, so I'm really small to try and squeeze it in. Okay. With that in mind, we're going to talk about what this graph looks like. Okay? No, I'm not asking you to grab the calculators. I'm asking you to use your brain. Oof. Okay, don't make the graph too big. I might have made my graph bigger than what I wanted. Oh well. Don't make it too big. I've got stuff to write in on the right there.
Oh.
Lots of stuff. Okay. What do you know about this graph? There's going to be a vertical asymptote at 2, yes? There's that invisible dotted line that my graph never crosses or touches. And what else did we just talk about? There's a horizontal asymptote at 0, which is the x-axis. Now, keep in mind, horizontal axes or horizontal asymptotes, technically a little bit different. I mean, general rule of thumb, asymptotes never cross, never touch. Horizontal asymptotes, you never cross, never touch as you go out towards the ends. But beware, in the middle, they can cross. Okay? Kind of a little weird thing there. But, do you see how these asymptotes created 4 sections, yes? Okay. Well, I don't know if you guys remember, your reciprocal function, I think we called it? It was one of our 12. The reciprocal function was the graph that went this way. Sorry, I'm backwards from you guys, so I have to pause and think. Okay? That's basically what this graph is, but moved 2 to the right. Okay? So we have a graph here that is in this upper right-hand corner. Then we cross the vertical asymptote. When you cross the vertical asymptote, you switch signs, generally speaking, and you have this piece down here. Okay? That's the graph we're looking at. Now, am I expecting you to magically be able to graph that by hand on your own? No. I'm expecting it to be familiar. I'm expecting as you look at your graph, you're going to be like, yeah, that makes sense. But no, we're not necessarily 100% at the, okay, I graphed that perfectly without looking at a calculator. Okay, we're not there, but we're working there. Does that make sense? Okay. Now, with this in mind, you have the graph. Obviously, you're going to be able to use calculators in homework where necessary to help you know what the graph looks like, most definitely. Our job is to talk about the domain. So, what we're going to look at here is limit. We're going to do this in limit notation. And the limit as x approaches certain values. What is our key x value here? The key x value is that 2 that caused the problem, yes? So when we start talking about domain, we're going to set up the limit as x approaches. And what we're going to do is we're going to talk about 2, but we're going to look at it from both sides. So we're going to look at the limit as x approaches 2 from the left of f of x. Okay. Now, limit notation. Not half bad on the quiz, but definitely a little bit of room for improvement. Work on your limit notation setup. Okay? So, this is
minus f of x?
that is, okay. And I was going to come back to that because I'm not sure if we've done that or not. This negative is a negative after the 2.
Okay.
It's not on the f of x. It's after the 2. And what it says is, as x approaches 2 from the negative side, or from, there's a more official description there. That's what I always say, though. As x approaches 2 from the negative side. Okay? Which, and in fact, I'll even write that down here. As x approaches 2, I guess what I always say is from the left. Now, from the left as in from the x, or from the negative side, yes? So this is one thing we're going to answer. The other piece of information we're going to answer, I'll come back and fill in my answer here in a moment, is the limit as x approaches 2, guess what? From the positive side, aka the right side. So the limit as x approaches 2 from the positive of f of x. And, for reference sake, This is as x approaches 2 from the right. Now, are you telling me we haven't done the approach from left and right part before? Okay. Sorry, I just need the reminder. Sometimes I don't remember where you guys are at. Okay. So, easy answer though. Okay. The limit as x approaches 2 from the left. That means I'm going to hop on my graph here, hop on my blue graph, I'm going to follow it. I'm going to approach 2 from the left, which means I'm going to hop on my graph over here. As I hop on my graph over here, I'm going to follow, 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 follow. As we get closer and closer to x equals 2, where's my graph going? Down. What's a mathematical word for down?
Negative.
Negative infinity. Okay. So that is one of our answers. And, okay, there's your, I'm giving you cheat words today, right? You got to understand what all this means. Now what about the next one? The limit as x approaches 2 from the right. So now this means I hop on the graph on the right-hand side, and I follow this graph, tracing, 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 as we get closer and closer to x equals 2. So basically, as I get closer and closer to that asymptote, where's my graph going? Up. And my mathematical word for up is positive infinity. And then we throw in a little Buzz Lightyear too, right? Okay. So I think maybe the first 2 or 3 problems in homework talk about finding the domain. Okay, we're not ever just finding the domain today. We're writing it in limit notation. Okay, this is limit notation domain because we're talking about 2 is our value that has an issue, right? Because it's where the vertical asymptote is. So what's my graph doing on either side of 2? That's what you're always going to be expressing. When there's a vertical asymptote, what is it as x approaches that number from the left and from the right? Okay? Now, officially, that is all this problem asks me to do. Okay? So officially, we're done with this problem. Now, in kind of getting us ready for down here, we're going to throw on something else. Okay? And that is what we just did there. This was horizontal asymptotes. Nope. This is a vertical asymptote. Yes? Now, let's talk, I'm just going to kind of squeeze it in here, about what it would look like if we did the horizontal asymptotes in limit notation. Okay? Now, horizontal asymptotes are a different beast. We're basically going to flip-flop our numbers and our infinities. Horizontal asymptotes, the question is always the limit as x approaches negative infinity of f of x and the limit as x approaches positive infinity of f of x. Okay? Just using this small little, trying to use this small area here. Now, are you working to write your limit notation properly? Okay? No, you can't just leave off the word limit or leave off the f of x or, you know, it's all official notation. Now, look at your graph. The limit as x approaches negative infinity. So, as I follow my graph to the left-hand side and as I head to Mr. Arnold's room, what's my graph doing? As my x approaches negative infinity, what y value is it approaching? No. As I trace this, right, I'm tracing this. We're following over here, following over here. We're going to keep going towards Mr. Arnold's room. We're officially getting closer and closer to 0, which is your horizontal asymptote, yes? So that's an equal 0. Now we're going to repeat the process on the right side of the graph. Okay? As I hop on my graph and I head off to positive infinity. So that means over here, it's as we hop on the graph and we head over to positive infinity. What's my graph approaching as we head towards Mrs. Fernum's graph? It's approaching 0, just 0 from above instead of 0 from below. Because what's happening? That's my in behavior. As that graph is going off to infinity both ways, it's getting closer and closer to that horizontal asymptote. Okay? And we'll talk about this more as we go through our middle set of examples here today. But horizontal asymptotes are always going to, your limits are always going to be as x approaches negative infinity and positive infinity, and it's always going to be equal to your horizontal asymptote. Whereas vertical asymptotes, we're going to do x approaches the vertical asymptote from the left and the right, and it's going to be equal to positive and negative infinity. Okay? You're going to do a lot of this in homework. Okay, questions I should answer there. Okay, I already mentioned all of this, I think. In behavior asymptotes, whenever you're asked about in behavior, they're basically asking horizontal asymptotes. What's your graph doing? Off on the ends. Vertical asymptotes, where the denominator equals 0. Okay, so part 2 here. The directions are find the asymptotes. Okay, yes, we're going to find the asymptotes, but we're going to express these asymptotes all in terms of limits. Okay, what's going on in terms of the limit. So, without looking at any graph, just looking at the equation, what asymptotes do you notice? What'd you say?
X plus 3.
Okay, x plus 3 can't equal 0, so that means what? Right. And I didn't even necessarily write this out on my paper, but so yeah, we know there's going to be a vertical asymptote, x equals negative 3. What else do we know?
Highest powers on bottom.
Highest powers on bottom, so there's going to be a horizontal asymptote of y equals 0. Okay, we'll review all the rules before we get done today for horizontal asymptotes. But the rule we have reviewed so far, largest power on bottom is y equals 0. Okay, we did our horizontal asymptote, I think it's back in lesson 1.2, which that's one of those lessons that took me like a week to teach and 3 different homework assignments to go with it. You need to refer, I think it's lesson 1.2. Okay, now, okay, so we have this x equals negative 3, right? So for a vertical asymptote of x equals negative 3, we don't have to know anything about the graph yet, but I'm going to set up 2 limits. Vertical asymptote is going to be like this. So my limit is going to be as x approaches negative 3 from the left and from the right. I keep going up. We don't know what it does, okay? But that's what we're going to look. So we're going to write these limits out. The limit as x approaches 3 from the left of f of x equals, okay? And I'm just writing these out. We'll come back and fill them in here in a moment. Fair enough? And the limit as x approaches 3 from the right. So those are going to be, once we get those done, those are going to be my 2 vertical asymptote limits. Okay? Now, trying to remember what I have done with graphs on this section in the past, and I really don't remember, to be honest. By all means, whatever you need to graph on the calculator and homework, do it. Okay? But don't be afraid to try and pause for a moment and think, what's it going to look like? If we look at this on the graph real quick, vertical asymptote at negative 3, yes. Horizontal asymptote at y equals 0, yes. This is basically just like above, except there's a 2 on top, which just affects your stretch a little bit. Okay? but this is a graph that has moved 3 left. So the graph looks like such. Your calculator would agree with me. Okay? Now, with this graph, can you answer the 2 questions that are over there? The limit as x approaches 3 from the negative side, or as I say, from the left. What's that going to be?
Negative 50.
Do we agree or disagree? As we approach negative 3 from the left, where's my graph going?
Go down.
It's going down. Negative infinity. Agreed. Okay. As x approaches 3 from the right, where's my graph going?
Positive infinity.
Agreed, disagree?
Agree.
It's going up, so positive infinity. Are we good with that half the problem? Now, the other half of the problem, we already talked that there is a horizontal asymptote of what?
0.
Y equals 0. Now, when we do this, limits for horizontal asymptotes are always going to be the limit as x approaches negative infinity of f of x and the limit as x approaches positive infinity of f of x. Now, reality is, I would argue you don't need the graph at all for this one.
Would be 0, 0.
0 and 0, because my horizontal asymptote is determining what's going on either end of the graph. Okay? And so here, as we go off to negative infinity, we're approaching 0 from underneath. As we go off to positive infinity, we're approaching 0 from above. Now, it's not unheard of to see limit equals 0. You will see me do that a lot as opposed to saying equals 0 equals 0. Just trying to connect the fact that they are always going to be the same. So did you see what I did there? I said the limit as x approaches negative infinity equals the limit as x approaches positive infinity equals 0. Now, does that mean you can't just put equals 0 on both of them? No, it doesn't. Okay, questions there? Ready to try B? Okay. Eyeball it. What do you know about the asymptotes?
X can't equal 2 and cannot equal 7/3.
Wait, no, there's 3.
Okay, so vertical asymptote is going to be x equals 2 because vertical asymptote is solely based on the denominator. Can my numerator equal 0? It can. And in fact, 3x minus 7 would be a x-intercept is what that would be. Okay, we'll talk about that down at the bottom. But where your numerator equals 0 is going to be an x-intercept. So we'll talk about that on our graph down there. Now, horizontal asymptote rule.
Would it be talk about
My powers are the same. When the powers are the same, you use the coefficients of those. What are my coefficients?
1 and 3.
3 and 1. And so it's going to be 3 over 1, which is indeed 3. Does that sound familiar? We've done this year. It's just a matter of getting it all straight in our head. Okay. So I'm going to start with vertical again. My vertical asymptote was x equals 2. Now, I only have one vertical asymptote. Here's the deal. For every vertical asymptote, you need to write how many limits? We're going to write 2 limits. Do you guys know what you're writing here? The limit as x approaches 2 from the left. And we're going to write the limit as x approaches 2 from the right. I haven't even touched a graph, have I? We haven't even talked about what the graph looks like, and that's fine. We'll get there in a moment. But those, for every vertical asymptote, you write 2 limits. Now, what if a problem has 2 vertical asymptotes?
4 limits?
4 limits. If a problem has 3 vertical asymptotes?
6.
You get the idea, right? Okay? I did not say that. Okay. Now, we'll look at the graph here in a moment. But let's talk horizontal real quick. What was my horizontal asymptote?
3.
Y equals 3. Can you write out the limits?
Yeah.
Horizontal asymptotes, you're always asking yourself the limit as x approaches
Negative infinity.
negative infinity of f of x and
Positive infinity.
the limit as x approaches positive infinity of f of x. So we talked about what the answer is to those.
3 and 3.
You guys agree with them? It's a horizontal asymptote. We haven't looked at the graph, but we're going to here in a moment. But horizontal asymptote, the limit as x approaches negative infinity equals the limit as x approaches positive infinity, which equals 3. Now, my graph last time kind of got big. Yeesh. Okay, sorry. Got to think. I'm going to put my x-axis low because that horizontal asymptote is high. So what do we have? Vertical asymptote at 2. Horizontal asymptote at 3. Well, right there, you pretty much know your graph has to be 2 opposite quadrants, right? So, and we'll talk about more later, but it ends up being kind of an opposite quadrants from what we've been doing. And that has to do with my horizontal asymptote being up and not at 0. Okay, because we are still on the positive side of the x-axis then. It also has to do with there being an x on top. Multiple different things here. Okay. I said x-intercept of 3/7 earlier, didn't I? I meant 7/3. Okay, there's an x-intercept of 7/3, so basically where your numerator equals 0. Again, talk about that later. Okay, based on this graph I just sketched for you, your calculator would agree if you graphed it on the calculator, right? What do we know? As x approaches 2 from the left, what's my graph doing?
Positive infinity.
It's going up, up, and away, right? So positive infinity. No one disagreed, so I'm assuming we're okay with that. What about as x approaches 2 from the right?
Negative.
Now I'm coming over here, my graph's going down, 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 so negative infinity. Is the TV doing weird things? Is that what-
long turned off the views change in the PowerPoint.
Okay. Oh, he just got here. He was out this morning, so. Okay, are we good with this? Okay. Let's look at C real quick. C is a different beast. We've got to throw it in. Okay. C, what do you know just eyeballing this?
This is bigger power on top.
Okay. He skipped to the vertical and said, I'm going straight to horizontal. Fair enough. Bigger power on top. Do you guys remember what the rule is for bigger power on top?
There's none.
There's no, like,
There's
why is
none.
nothing? Yeah.
Okay. When the bigger power is on top, then there are no horizontal asymptotes. Which means, are there any limits to write then for a horizontal asymptote? No. Okay. What about vertical asymptote?
X equals plus or minus.
To Ron.
Check your math.
Check the map.
I mean, -1.
Yeah, that's negative.
If x squared plus 1 equals 0, x squared equals -1. What's the square root of -1?
I.
Plus or minus I. Do we have imaginary asymptotes?
Yeah.
Yeah.
No.
There are no vertical asymptotes. And guys, think about this way. Give me a number that makes my denominator equal to 0, a real number. Can x squared plus 1 ever equal 0? No, because x squared is always going to be a 0 or positive, and then you add 1, you're going to have a positive. That denominator can never equal 0. So there's no horizontal, no vertical. Now, what there is, and I want to, okay, so when there's no horizontal, what that means is that there is something called a slant asymptote. When I say slant asymptote, I mean a diagonal asymptote, okay? In order to get that slant asymptote, it would be along the lines of dividing, whether like long division, synthetic division, but it would be dividing your numerator by denominator. Generally speaking, what's x to the third divided by x to the second? X, yes? All I have written down in my notes is that your slant asymptote would be y equals 1x. Now, I don't, for the most part, there's not slant asymptotes in homework. I think there's maybe one, and it's not on a limit section, okay? But, graph this on your calculator real quick, okay? Because slant asymptote takes the place of horizontal asymptote, so we can still say the limit as x approaches negative infinity of f of x, and the limit as x approaches positive infinity of f of x. Are you getting a how do I ask this? Are you getting a diagonal asymptote? Not that you see a diagonal asymptote, but do you see a diagonal feature happening?
Yes.
Am I making sense there?
Yes.
Okay. There's definitely a diagonal thing going on there, isn't there? Okay. I'm curious.
I didn't know it looked like that.
Okay.
Wow.
Now,
This kid.
what I just put in is the red line I just put in is y equals x. That y equals x represents the asymptote. Do you see my graph running along that diagonal line? Okay, so I know I skipped the part of getting to y equals x, but it would be a division. You could use synthetic division, long division. Rephrase, you can't use synthetic division. It'd have to be long division officially. Okay, but that's the gist of what we've got. Now, let's answer these limits. The limit as x approaches negative infinity. As my graph goes off to the left, where is it going? As we're going to the left, it's going where? Down, which is
Negative infinity.
negative infinity. Notice I wrote that one in separately. Is this like a horizontal asymptote where they equal each other? No. Now, as x approaches positive infinity, as my graph goes off to the right, where is it going?
Up.
It's going right and up. So this is positive infinity. Okay? Again, your homework is more focused on vertical and horizontal. However, does that mean slant asymptotes don't exist? No, it doesn't. They still exist. They still pop up. Our focus, though, is more vertical and horizontal. Okay. As I said, hopefully I'll get a chance. Homework. Majority of your homework is writing limits. Lots and lots of limits, okay? Now, we're going to go down to the bottom, and we're going to talk about graph B, okay? We're going to graph this, for the most part, by hand, okay? In order to do this, there's 4 things up there we need to know. Let's work our way through this on part B, okay? So first of all, number 1, we need to know end behavior asymptotes. When I say end behavior asymptotes, that's a fancy word for what? Horizontal. And officially it could be horizontal or slant, but generally speaking it is horizontal. What do you got for me? You with them? Horizontal asymptote, y equals 0 because, yep, bigger power on bottom. Okay, could you go ahead and put your horizontal asymptote in here? You certainly can. Okay. 2.
X equals -2 and a +3.
What do we have to do?
I'll be honest, I don't know.
Factor. So x squared minus x minus 6. So let's take a moment. X minus 1 doesn't factor. X squared minus x minus 6. Are you going to have to do some factoring today?
Yeah.
Yes.
Is there going to be some canceling?
I don't really think so, because I don't have anything about holes in my notes. Okay, and you remember that, right?
Yeah.
If a factor on top and bottom cancels, it's not a vertical asymptote, it's a hole. Okay, something about 3 and 2. What?
-3.
Minus 3 plus 2 is what's in my parentheses. So what's my vertical asymptotes?
X equals 3 and -2.
Oh, we have 4.
Are you guys with them? X equals 3 and -2, and that is your denominator equal to 0, yes? I'm just writing stuff down. I didn't hear a knock at the door, did I? Okay. See, anytime I ignore it, it's actually a knock at the door, but okay. 3.
X equals 1.
Okay. I mentioned x-intercepts earlier, didn't I? X-intercepts are officially x-intercepts happen when y equals 0. That's what you were taught back in algebra. That's what we reviewed probably first semester at some, or earlier this semester at some point. But when y equals 0. Well, when y equals 0, when does a fraction equal 0? When the numerator equals 0. So the shortcut is to just say when the numerator equals 0. And so, what kind of x-intercept am I going to have? X equals 1. And that could be 1, or if you want to get fancy, 1, 0. I don't have a preference right now. Okay? And, oh, I quit putting anything on the graph, didn't I? Oh, well. 4. When do y-intercepts happen? When x equals 0, right? So it says what f of 0 equals. What's that saying? That's saying put 0 in for x. Okay? 0 minus 1 is -1. 0 squared minus 0 minus 6. So we're going to have a y-intercept of, what's -1 over -6? Positive 1/6. Or if you want the ordered pair, 0, 1/6. Okay. Now, back to the graph. Okay. We already talked about the horizontal asymptote, and then I failed to talk about anything else on this graph. Vertical asymptotes. Okay, so there's 3 and -2. Are you guys good there? Okay. X-intercept of 1. What's that going to mean?
That's gonna go through 1.
My graph is going to cross the x-axis at 1. Now, that's going to cross through a horizontal asymptote, isn't it? But do you guys remember what I said? It's the ends of a horizontal asymptote that you can never cross or touch. The middles, you can't. Okay? Now, what else do we know? A y-intercept of, I'm going to put a tick mark. It's just, that's probably more than 1/6 above, but I was trying to make it visible. Okay. Now, so what do we know? Our graph is going to be broken into not 2 pieces, but
4, 3.
3, right? 1, 2, 3. And, okay, with this in mind, something we haven't really talked about, but it's really just a matter of knowing where to start. And general rule of thumb is we had positive x squared, it's a positive fraction. We always start at the right of a graph, and we're going to start above the x-axis. So if I'm starting above the x-axis, okay, now that's right above the x-axis in this case because the x-axis is a horizontal asymptote. As we follow along this horizontal asymptote, where's my graph going to end up going? It's going to have to go up, isn't it? And it's going to run along that vertical asymptote. Maybe not quite that close because I made it really close, but that's all right. Okay, now, I have suggested at vertical asymptotes, there's a special rule later, but at vertical asymptotes, generally the rule is your sign switches. So if this was positive here, when we go on the other side of this vertical asymptote, my graph is going to be negative. So we're going to be coming from the bottom of the vertical asymptote. Now, a couple of different things that could happen, but what do we have to hit? We have to hit these points, don't we? So think about kind of like a cubic curve. We're going to go over here. We're going to cut through 1. We're going to cut through 1/6, and guess what? We're going to go up. Okay? If we didn't have an x-intercept there, that might have been like an upside-down parabola piece. Now, can you guess what's going to happen on the other side?
Yeah, flip.
Vertical asymptote, we've got to change sign. So instead of it being positive, we're going to be negative. And what's going to happen? Up and to the left. Now, do I expect you to ace that on your own? No. Can you put some thought into it, though, and think about it? There's a lot of little things you guys don't know yet. Okay? And so that's why I'm not 100% saying you've got to be able to graph this on your own. No. However, can you come up with the 4 pieces that led into this?
Yes.
Yes. And that is an expectation. Because come test time, that's going to be more what I'm testing than the graph, because the graph you can always just plug it into your calculator. Okay? Yes?
I'm confused on how you love that.
The x-intercept is going to happen whenever you put your numerator equal to 0. So my numerator was x minus 1. So I just set x minus 1 equal to 0. Okay? And then, of course, add 1 over and x equals 1. That's your shortcut there, is you just set the new. If it's not a fraction, we have to make y equal 0. Okay? Now, okay. You got evens, all evens. Make sure you do the all in that middle part, right? Now, okay, so 2 through 10 evens. Please listen. 2 and 4. Find the domain. Use limits. So that means you only have to write the limits for the vertical asymptotes officially. 6, 8, 10. Basically, 6, 8, and 10, I want you doing all asymptotes. So, however many vertical asymptotes there are, you need 2 limits each. There's only going to be 1 horizontal asymptote, if there is one, and you need how many limits? 2 limits per asymptote, right? So find all the asymptotes, 2 limits. 11 through 18, you're looking at a graph that's in the book to answer the questions. Okay, those are easy. 22 is like what you did earlier. Use all your limits. And I'm trying to remember, 24 through 30 is more like what we just did on B. Okay? I don't have the graphs in my answer key, but I want you finding asymptotes, intercepts. Okay? Okay, guys. Let me know what questions you have.
Thank you. Have a good day.
My very to the structure here.
I can. Let me,